Good morning, dear students. Today's class we will discuss about analysis of some sorting algorithm, and in that case we will discuss about bubble sort and selection sort. In the last class we were discussing about analysis of insertion sort, and there in the insertion sort we have told that how to sort the algorithm elements in ascending order by taking elements one by one and inserting into in the sorted sub-array in its proper position. And in that case we have analyzed that in case of insertion sort we have analyzed that in the best case it will be the time complexity is order of n, whereas in the worst and average case it is the order of theta, n square theta, that means order of n square. And here we will discuss about bubble sort. In bubble sort, what is the sorting strategy? See, in this case what happens, you repeatedly pass through the array. That means if you have n array elements and you want to sort it in ascending order, then from starting from I is equal to 1 to n, I is equal to 1 to n, you have to pass, and in each pass, you have to compare two adjacent elements. You have to compare two adjacent elements starting from the last array content, and you compare from two adjacent elements and you exchange. If one is smaller than first one is smaller than the previous one, then you exchange it, and in this way you proceed. That means you have adjacent elements that are out of order. See, in this example, you have the elements 8, 4, 6, 9, 2, 3, 1 is given, and you want to sort using bubble sort algorithm, and in that case I will be 1, that means it will be first pass. How many passes will be there? Because there will be n passes, where n is the number of elements, and in the first pass what will happen? You have to compare the elements starting from the last element towards the beginning element, and in each comparison you have to swap the elements, swap the two adjacent elements you have to compare, and you have to swap the elements if they are out of order. And we will see that this algorithm is easy to implement, but slower than the insertion sort. How it is slower than the insertion sort, that we will go to. See the algorithm. First, your I will be 1. For this example, first of all, what happening? I have to, there are 1, 2, 3, 4, 5, 6, 7 elements, and hence there will be how many passes? There will be 7 passes, and in each pass we will start from the end of the array and we will compare the two adjacent elements, and in this case I will be 1 and your j will be 1 and j will be 1, hence you will compare the elements aj with aj minus 1. That means here 1 and 3 will be compared. You see the first array figure, 3 1 will be compared, hence 3 is greater than 1. That means 1 should be placed in the left of 3, and because in you are sorting in ascending order, hence 1 3 you have exchanged. Now j will be n minus 1, j will be n minus 1. First j was n and you are comparing with j is equal to j is equal to n, and you are comparing with j is equal to j minus 1, that means n minus 1. Now j becomes n minus 1 and you are comparing with its previous element, that means here 1 is compared with 2. Now 1 to 2 is bigger, hence you are exchanging 1 and 2 for the same value of I, for the same pass. In the single pass we are doing here. Now j becomes n minus 2 and j is equal to n minus 2, whose value is now 1. Now it will be compared with the 9, that means j minus 1, 9. Now 9 1, 9 is bigger, hence you are exchanging 9 on 1. Now you see, now again 1 will be compared with 6 and 6 is bigger than 1, hence then you are exchanging 1 and 6. Okay, now 1 is compared with 4, 4 is bigger and you are exchanging 4 and 1, and then 1 is compared to the 8 and hence you are exchanging 8 and 1. Now in this one pass, this is one pass, in one pass you are comparing the adjacent elements starting from the higher order of the array, higher order value means higher order index of the array, and its corresponding or in its nearest element. If they are in out of order, you are exchanging, and it will go up to the value of I. Here I was 1, hence you are going up to the value of I and you are exchanging. This is the first pass. How many passes will be taken place here? Here it will take place the number of elements. Here the number of elements is 7, hence the 7 passes will take place, and in each pass what happens? Starting from the last index of the array, you are comparing with the second last index. Like this you are comparing and exchanging if they are out of order. In this way you are reaching up to I in a particular pass. Now in the second pass I will be 2. Now I will be 2 because in the first pass I will be 2. Hence in this case what happen? You see the first element is already 1 is already there and it is sorted. Now in the second pass what will happen? In the I is equal to 2, and now again in the second pass you have to compare the elements starting from the last index of the array to its previous element. Now 3 will be compared with 2, hence 3, 2, they are not out of order, hence there will be no exchange. Now again j will be n minus 1, 2 will be compared with 9, hence 9 is, you see 9 is greater than 2, 2, 9 will be exchanged, and now 2, 6 will be compared, and 6 is bigger than 2, hence 6, 2 will be exchanged, and 4, 2, 6 will go exchanged, and 4, 2 will be compared, hence 4, 2 will be exchanged, 8, 2 will be compared, hence 8, 2 will be exchanged. And in this case the final pass will be 2, 8, 4, 6, 9, 3. Because in this you see for I is equal to 2, you are 3, 2 you are comparing, you are placing 3 or up 3, 2, there will be no exchange because 3 is bigger than 2. Now 2, 9, hence you are placing 9 and placing 2 in 9 position. Then 6, 9, because 6 and 2, now 6 will go to 2 position and 2 will go to 6 position, and 2, 4, and 4 will go to 2 position and 2 will go to 4 position, and 2, 8, 2 will go to 8 position and 8 will go to 2 position, and this is the in the second pass this is the result. Now hence in the I is equal to 3, because I was 2, this becomes the result. For I is equal to 3, what happens again, this is the third pass. And remember, you see in the first pass, that means the first smallest element you are keeping in its position. First smallest element you are keeping in its position. And you will say in the second pass, the second smallest elements you are from the right you are taking and you are keeping it in proper positions. Okay. And in the third pass similarly case happens. 3, 9, you see 3, 9 will be exchanged, 6, 3 exchange, then 6 will go, then 4, 3 will be exchanged, 8, 4 will be 3. That is in the I is equal to 3, the third element, smallest element is placed in its position. And that means in bubble sort, in each pass, in the first pass, the first smallest element you are keeping in its position. In the second pass, the second smallest element you are keeping in its position. In the third pass, the third smallest element you are keeping in its position. How you are doing this? How you are doing this? Because in every pass, you are starting from the last end of the array and you are comparing the two adjacent elements. Which one is the smaller? Which they will close towards the left. If the right hand is smaller, then you are exchanging. Then this, and then second comparison will be done with the n minus 1 R index with the n minus 2 R index, and if they are out of order, again you are shifting it. Like this, it will happen in the same way. For I is equal to 4, the fourth element will be placed in its proper position. For I is equal to 5, the fifth smallest element is placed in its proper position. For I is equal to 6, the sixth smallest element is placed in proper position. And for I is equal to 7 and j is equal to 7, by default it will be placed in this position. Okay. Hence, and finally, this is the sorted array. Hence, what happens in bubble sort? In bubble sort, the first you have to, depending on the number of elements, that number of passes will do. That means if you have given 7 elements, then 7 passes you will do. 7 number of outer loop you have to run. And in each outer loop, what you will do, you have to compare starting from the last index element with its previous index element if they are out of order. That means if they are out of order means if the last end is the small and the previous end is the previous one is the bigger, then you are exchanging. In this way of exchanging, you are coming towards the pass value. Here pass value in the first case, pass value I is equal to 1, coming to the pass value. And doing this exchanging, you will finally what will happen? The smallest element will be gradually shifted towards left and it will place in its proper position. This is the bubble sort. Now let us write the algorithm for this. Hence for this algorithm what will happen? First of all, it indicates that number of passes for I is equal to 1 to n. That means for I is equal to 1 to n you have to write. For I is equal to 1 to n, what you will do? Then there will be another loop for making the exchange. Hence for what will happen? For I is equal to 1 to length of A. Length of A means the number of elements. For j is equal to length of A, because from the last element you are comparing with previous element, so hence j value will be length of A or the last index array. Down to I plus 1, because you will go up to I plus 1 and you will compare with the AI element. That's why j is equal to length of A down to I plus 1. Do if Aj is less than Aj minus 1. If Aj is less than Aj minus 1. That means if the right hand element is less than the left hand element in the comparison, then you will do the exchange. This is the bubble sort algorithm. If doing this exchange, how many times you will do inside the for a particular pass, you will do the comparison up to what is up to your ith element. Up to ith element you will compare from starting from the j, you will go to I plus 1. Hence this way the sorting will taken place. As it is happened, see I is equal to 1 and j is equal to your n here, and 1 3 will be compared, 3 1 is less than 3 3 will be shifted, as I have already discussed in the previous slides. See, this is the, now we will discuss the analysis of the algorithm. That means what is the time taken by the algorithm. Now see, for I is equal to 1 to length of A. Suppose I am saying that this statement will take C1 time. For I is equal to 1 to length of A, this statement takes C1 times. For j, do for j length of A down to I plus 1, this statement will take C2 amount of time. Next statement for Aj is less than Aj minus 1, this will take C3 times. Like this exchange will take C4 times. Now suppose this is the, for each one time if it will run, then it will, that means every running of this instruction it will take C1, C2, C3, C4 times. Now question that how many times does this particular instruction will run? Say for C1 how many times in that for I is equal to 1 to length of A will run, because C1 how many times will run? It will run 1 to length of A. That means n times it will enter inside the loop, but for n plus 1 times it will out of the loop. Hence Tn will be C1 into n plus 1. Tn will be C1 into n plus 1. Now for C2 how many times it will run? See, for the second instruction, for j is equal to length of A down to I plus 1. For this, for j length of A down to I plus 1. Then how many times it will run? For the outer for loop, for a particular value of outer for loop, what happens? What is the maximum value of outer for loop? That means I value for j, for a particular value of I, j will be length of A. That means A down to I plus 1. Length of A is n down to I plus 1 means how many times? N minus I plus I minus 1. N minus because it will see length of A down to I plus 1. Then that means down to I minus 1 times it will run from for j length of A down to I plus 1. Hence length of A means n down to I plus 1, up to this it will run, but up to I okay, that means what happens? It will run n minus I plus 1 times. N minus I plus 1 time where I is equal to 1 to n. I is equal, because for I is equal to 1 to n, this will enter into the loop, and hence this will run n minus I plus 1 time. Now for the C3 case, it will be just 1 less than that, because the condition will fail once and it will not enter inside the loop. Hence C3 into I from 1 to n minus I. Similarly for C4 instruction, C4 unit, how many times C4 times it will be? It is a summation of I 1 to n minus I. Is this clear? Now hence what will happen? If you do it, summation over I n minus I, summation over that will be 1 will be theta of n, then C2 plus C2 plus C4 into summation over n minus I into n, I from 1 to n, and this is nothing but your, it is given, it is n square by 2 minus n by 2, n square by 2 minus n by 2. Hence Tn will be theta of n square. Hence bubble sort algorithm will run order of n square, tied 1 by n square. Now in this case, why there is no best case, worst case or average case? Because whatever may be the arranging of the previous arranging of the elements, your outer loop will n times and your inner loop will run also n minus I plus 1 times, irrespective of the arrangement, because this is without any condition it will go. But here the exchange may not take place, may take place depending on the arrangement. Hence the exchange may do or may not do, but the whatever may be the position of the elements, prior knowledge of the element or prior position of the element, the 2 for loop will run. As in case of insertion sort, that is in case of best or worst case, the time complex is changing, but here it is not like this, because whether it is a best case, worst case or average case, the 2 for loop will run same times. Hence in this case what happens, for n, irrespective of the input, the bubble sort will run n square time. And you see how many number of comparison will done? It will done n square by 2 times, because the number of comparison is same as your C3 into n square minus I. That means n square by 2 minus n by 2 times. N square by 2 minus, that's why it is comparison is approximately n square by 2. Actually the number of comparison is n square by 2 minus n by 2. Actually the number of comparison is n square by 2 minus n by 2. Then how many exchange will be done? Exchange, see, comparison you have to compare, whether it whatever may be the position of the elements. But in the exchange it depends on whether it is less than or greater than, and at max the exchange will be at max the exchange will be n square by 2 minus n by 2. If the elements are arranged in as descending order and you are sorting in ascending order, in that case the exchange will be n square minus n square by 2 minus n by 2, n square by 2 minus n by 2, or in nearly equal to n square by 2. Okay. Otherwise the time complexity of the bubble sort algorithm is theta of n square. Now you see, if you will compare this bubble sort algorithm along with your insertion not sort algorithm, see, insertion sort algorithm is somewhat better than bubble sort algorithm. Why insertion sort algorithm is somewhat better? Because in bubble sort algorithm, it will take theta of n square irrespective of the way of the input is coming. But in insertion sort, it sometimes take theta of n square, it sometimes set big of n. Okay. Sometimes, hence at least sometimes it is giving taking less time. That's why this in time comparison, this is the insertion sort is better than the bubble sort. And the comparison and exchange, they are also small. Now let us take another example of sorting algorithm, that is your selection sort. In the selection sort, what is happening? See, in the bubble sort, what is happening? We are placing in the first pass, we are placing the first smallest element to its position. But in that case, what happened? In each pass, we are exchanging, and in last exchange we are placing the value. But why we do exchange many times? The question is that why we will do exchange many times? If you are finding that the smallest element is there and at last we can do exchange, because in the insertion sort, sorry, in the bubble sort, what is happening in first pass? We are taking the first smallest element and placing it in the in its first position. In the second pass, we are taking the second smallest element and placing in its proper position. But in this way, while we are selecting the elements in case of bubble sort, what happens? We are continuously doing the exchange. But the question is why we will do the exchange? Cannot we avoid the exchange or avoid the exchange? That is happening in the selection sort. Hence, in the selection sort, what is the idea? Find the smallest element in the array, exchange it with the element in the first position. And before that, there will be no exchange. Here, that will happen. We are just exchanging, and we are finding the smallest element, and at last, exchange is the smallest element we are placing in the first position in case of bubble sort. But here, what happens? We will find where is the smallest element, but no exchange will be done, and at last, the exchange will be done with the first position. Similarly, we will find the second smallest element, and the exchange will be done in the second position, and this will go on continuing, and finally, when all the elements, first elements, first smallest element, second smallest element, third smallest element, we will find arranging it. Then our what is our sorting algorithm will be complete. And the disadvantage is that running time depends only slightly on the amount of order in the file. Here, ordering the running time depends on the order. Let us check what is happening. See, this is the case. The same example we have taken 8, 4, 6, 9, 2, 3, 1. This is the example, and we want to sort it in ascending order. Now, we have in this case, in the first position is where the 8 is there. In that position, the smallest element should be there. In fourth position, the second smallest element will be there. In the third position, that is where 6 is there, the third smallest element will be there. This is the way. That means what we will do. See, in this first pass, we will see position 1 is the smallest element. 1 is the smallest element, and that will be placed in the 8th position. Hence, 1 and 8 will be exchanged. And the next what will happen? Next smallest element is 2, and it will come to the second position. Third smallest element is 3, it will come to the third position, and that exchange will be. And fourth smallest element is 4, it will come to the fourth position. And fifth smallest element is 6, and it will come to the fifth position. Sixth element is 8, it will come to the 8th position. Like this, it will do the sorting. Okay, now this sorting. This is the sorting algorithm. How it is happening? See, and this is the algorithm, selection sort algorithm. N is equal to length of A. That means how many times we will place the elements, because there are n is the number of array. Yeah, hence at least n minus 1 times we will find the elements, which one is the smallest, which one is the second smallest, like this, because by default the last element will be in its proper position. Hence, j is equal to 1 to n minus 1. For j is equal to 1 to n minus 1. That means out of n element, if you are placing n minus 1 elements in its proper position, then the array will be by default sorted. Hence, first of all, we will do smallest is equal to j, because j is equal to 1, the first element, first position element, we will assume it is the smallest, but really it may not be the smallest element. And for j is equal to, for I is equal to 1 to n, for I is equal to 1, for I is equal to j plus 1 to n, j plus 1 to n. And then what will happen? Do if ai is less than a smallest, ai is less than a smallest, the smallest will be I. Smallest will be I. Then exchange aj with a smallest. Then exchange. See, you compare this with the bubble sort algorithm. Bubble sort algorithm was also doing the same thing. Same thing means the idea is behind is the same, but the exchange in every case, in case of bubble, it was the exchange. But here there is no exchange. Exchange will take place at the last. Hence, in this case, what is happening? See, for j is equal to 1 to n minus 1, because there are n elements, hence n minus 1 elements will be kept in this proper position. Hence, and in the beginning, the first element, smallest element will be in the position j is equal to 1. For j is equal to I, for I is equal to j plus 1 to n, for I is equal to j plus 1 to n, ai If ai is less than a smaller, see in this case, see what is happening. I am explaining. In the first case, your j will be 1, j will be 1, hence j will point to your first element, and smallest r index will be j. That means in the where 8 is there, this will be smallest element will be placed there. Or for timing we are assuming there is the smallest element, but reality there is not the smallest element. For j is equal to for i is equal to j plus 1, that means I will be 2. Now 4 and 8, which one is the small? 4 and 8, because the small will be 4 where I is pointing, hence smallest will be the ith position, the 4th position. Similarly for j is equal to 2, that means 6th position, no, smallest will not change because ai is not that a smallest, the smallest will not change. For I is equal to 3, 9, no, smallest will not change. I is equal to your 4, that means where 2 is there, then ai is your 2 and a smallest is your 4. In that case what happens? You will go on and at last your smallest will be at the position 1. Smallest will be at the position 1. And this you will exchange with aj and a smallest, as I have already discussed these things. Okay. Now we will compare, analyze the analysis of the selection sort. See, for the first case, suppose it is cost is C1 and the number of times it will run is 1. For the second, the cost is C2, number of times it will run is n. And now for the next, it will the cost is C3 and number of times it will be n minus 1. And next case, the C4 and the how many number of times it will run from n to what is j plus 1, j plus 1, n to j plus 1. Okay, that means n to j plus 1 means n minus j plus 1. N to j plus 1, because one condition will be failing condition, hence n plus 1 minus j times. Now similarly for j will be from 1 to n minus 1, because j will be 1 to n minus 1, hence your running will be n minus j plus 1, or j is equal to 1 to n minus 1. For next one, it is C5, it will run just 1 less than what the previous one is running, hence it is n minus j, j from 1 to n minus 1. In the last one, it is also the same, j is equal to n minus j, j is equal to 1 to n minus 1. In the next one, it is the out of the inside for loop, hence it is C7 into n minus 1. Hence Tn is C1, C2n, C3 n minus 1 plus C4, all the multiplication of C1 into 1 plus C2 into n, like this, it is the addition of these. And you see that in the previous way also how you have calculated the summation of n minus j. Thus this summation is in order of n square. Hence the time complexity of the selection sort is order of tide bound of theta of n square. See, the time complexity of the selection sort is same as the time complexity of bubble sort, because the selection sort follows the same idea of bubble sort, but there is certain variation. What is the variation? Every time in that case what happen? The exchange is taken place. The exchange is taken place, but here the exchange is not taken place. But while there we are for each pass in case of bubble sort, we are comparing from right element, right side towards the left. But here in each pass we are comparing the elements from left towards the right, and we are taking the smallest one and we are placing it. This way it happens. The idea is same. What is the bubble sort and selection sort? The time complexity is same, but the idea is slightly different. In case of bubble sort also, in each pass we are taking the smallest element and keeping it. In case of selection sort also, we are doing this. But in case of bubble sort, in every comparison there is a probability of exchange. But here there is exchange is not taken place. Rather, exchange is taking place at the last. Hence, how many type of comparisons will be done? Comparison will be done as same as the comparison of bubble sort. That is n square by 2 or n square by, actually reality it is n square by 2 minus n by 2. We are writing approximately equal to n square by 2, but in exactly it is n square by 2 minus n by 2. but in the exchange will not take place as it happens in case of your bubble shot. The exchange will not take place as it happens in case of bubble shot. The exchange will take place at how many times? Only n times. But in case of bubble shot, the exchange will take place same as the maximum number of exchange will take place same as the maximum number of comparison. But here the number of exchange will take place at max. The number of exchange will take place at max order of n. At max order of n. This is the difference. Okay. Otherwise, the time complexity of bubble shot is same as the time complexity of your selection shot. Okay, some mathematical background related to cheat. You see, log x to the base b is equal to y if b to the y is equal to x for all b greater than 1. This definition you know. Log of x of base b if it is equal to y if b to the y is equal to x, that you know. Log b is strictly increasing function. If x1 is less than x2, then log x1 to the base b is less than log x2 to the base b. This is the strictly increasing function. Log b of any value is 1 to 1 function. If log x1 to the base b is equal to log x2 to the base b, then x1 is equal to x2. That means if log x1 to the base b is equal to log x2 base b, then x1 is equal to x2. If log 1 base b is equal to 0 for all b, that you know. Log x to the power a base b is equal to a into log x base b, that you know also. This is the simple mathematics, plus 2 or 10th mathematics, you know it. Log x to the power a base b is equal to a into log x to the power x base b. Again, log x1 into x2 base b is equal to log x1 base b plus log x2 base b. These things, rules you remember, it will be used in consequent classes. Okay, this thing definition you remember. Next one is x1 to the base log x2 base b. x1 to the power log x2 base b is equal to x2 to the power log x1 b. That you remember. You can prove this also. This x1 to the power log x2 base b is equal to x2 to the power log x1 base b. This thing you can prove. It is a mathematical, but you remember this thing. It will be used in future classes. See, another is 7th rule is log x base b1 is equal to log x base b2 divided by log b1 base b2. This is formula also you know. Log x base b1 is equal to log x base b2 divided by log x b1 base b2. And this summation of a conjugative integer, that we have also discussed. Summation over I from 1 to n is equal to n into n plus 1 by 2. That means 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. This simple proof you have also done in the method of induction. And geometric sum a to the power I from 0 to 1 is equal to a to the power k plus 1 minus 1 divided by a minus 1. These things you also know. You remember and integration of fx dx is equal to from a to b plus 1 is equal to less than equal to summation of fi I from a to b, and is less than equal to integration of a minus 1 to b fx dx. This rule, 10 rule you remember, starting from 1 this and this rule. Okay, and in the next class we will discuss some different techniques of designing the algorithm. Hence, but till now these 3 sorting algorithm we have discussed. One is your insertion sort, and here what is the time complexity is sometimes we go of n and some we go of n and sometimes order of sometimes order of big O in case of if it is sorted, and sometimes it is what is it is order of n square. But in case of bubble sort, it is always order of n square. But here what the exchange will be, comparison will be n square by 2 minus n by 2, and exchange will be n square by 2, maximum n square by 2 minus n by 2. But in case of selection sort, it is same as bubble sort, but here the number of actions is reducing. Number of actions is reducing, but the time complexity, both of them are same. Okay, hence I am ending the class here.